Solving equations. An equation is a statement that two expressions are equal. It has an expression, an equal symbol, and another expression. The special symbol that it tells us we have an equation is the equals. So if we watch for the equal symbol, we'll know we have an equation. For expressions, we simplify, which means to remove parentheses and combine all like terms. For equations, we solve, which means to find the value, which makes it a true statement. If we stay on one side of the equal sign, we have an expression and we can simplify. We can also do the same on the other side of the equal sign. We will use both sides when we solve. Our goal when solving an equation is to isolate the variable. To help us achieve that goal, we perform the reverse operation on both sides of the equation to get rid of terms. We want to make things cancel out. Let's review our operations. We have addition, subtraction, multiplication, and division. When we solve equations, we want to reverse these operations. So if we have an addition, we can do a subtraction to reverse. If we have a subtraction, we can do an addition to reverse. If we have a multiplication, we should do a division to reverse. And if we have a division, we can do a multiplication to reverse that operation. Let's look at some examples. First, we have x plus 7 equals 12. You want to make sure that you learn the process. Don't just look at that and say the answer. I'm sure that most of you could look at that and say, well, 5 plus 7 would be 12, so the answer is 5. But you want to learn to understand the process. So we will first make sure it's an equation. It needs an equal symbol. Go on the side with the variable, and you're going to take off anything else. So to isolate our x, we want to take off this 7. The 7 is added to the x. So to make it cancel, we're going to subtract a 7. And we will have to do it to both sides. So this is what we had. Our new operation is we're going to take 7 away. So we brought down what we had, and we took 7 away. We brought down what we had, we took 7 away. Now we'll clean up, and this positive 7, negative 7 are going to cancel. Leaves us x equals, simplify on the right-hand side, 5. X is isolated. That was our goal. For our next example, x minus 5 equals negative 3. We want to isolate the x, so we go on that side. That means we want to get rid of this minus 5. To make it cancel, we should add a 5 to both sides. So we'll bring down what we have, and we will add a 5. You should always make sure your equals come straight down. Bring down what we have, and we will add a 5. So we added 5 to both sides. Clean up. X equals. On this side, you have to watch your signs. You have different signs. Subtract, sign of the larger, which will be positive. So we get x equals 2. For our next example, 1 equals y plus 3. This equation is just turned around a little bit. That's okay. We don't care if it looks backwards. You should go on the side with the variable to solve. So we should be on the right-hand side. There's the y. That means we want to take off the 3 so that we can isolate the y. The 3 is added, so we should take it away. So on the left-hand side, we need to take it away. You should write your new piece after. Bring your equals straight down. We'll write what we have on the right-hand side, and then we'll take our 3 away. Clean up. That one cancels. That was our goal, to cancel that piece out. On the left-hand side, watch your signs. These are different signs. Subtract, sign of the larger equals straight down, and keep your y. -2 equals y. Your y is isolated. That was our goal. For our next example, 3x equals 12. Go on the side with the variable, so you're on the side with the x. Notice the operation between the 3 and the x. They are side by side, so they're multiplied. To reverse something that's multiplied, you should do a division. So we're going to divide out the 3. When you divide, the division is the reverse. You always divide by the sign of the coefficient. The 3 will cancel. That leaves us x equals 3 into 12 will go 4 times. X equals 4. X is isolated. That was our goal. Our next example, -5x equals 10. Go on the side with the x. Notice it's right beside the -5. The operation there is a multiplication. To reverse it, you need to do a division, and you need to divide by the coefficient, which is a -5. So divide on both sides by a -5. Clean up. These will cancel. Leaves us a positive 1x equals a 2. You only have one negative sign. That's odd, so negative. X equals -2. Our next example, -x equals 4. This equation is not quite finished. You're not allowed to leave a negative coefficient on the x. So if we think of what our coefficient of the x is, it's actually a -1x. Then we would realize what to do. It's multiplied by the x, so we would need to divide on both sides by a -1. The two negatives would give us a positive x equals, divide, we get 4. We only have one negative. That's odd, so negative. So we have x equals -4. X is isolated. That's our goal. For this problem, go on the side with the x, and if we read it to ourselves, it says x is divided by 5. To reverse a division, we would do a multiplication. So to get this 5 off, we should multiply by 5. We need to do the same thing on the other side. Multiply by 5. And this will cancel. Will leave us x equals a positive 15. Solving formulas is a good way to make sure that we're okay with the process of solving equations. So they have to tell us which variable to solve for. It says we're going to solve for x. That means we want to isolate the x. So we're going to go on the side with x, and we'll take off anything else that's on that side. So x is here. That means we want to take off the y. The y is subtracted. So how should we cancel it? We should add a y to both sides. That will make it cancel. So this is what we had. We're going to add a y, so they will cancel out. We have to do the same thing on the other side. On the left, they will cancel. Leaves us x equals. On the right-hand side, we can't do anything. These are not like terms. But our variable x is isolated. That was our goal because that's the one we were asked to solve for. Let's look at another formula problem. And this one asks us to solve for b. That means we want to isolate the b. We should go on the side with the b, and we'll get rid of anything else that's there. So we want to get rid of the p. Notice the operation between the p and the b is multiplication. So to get the p off, we need to divide by it. Do the same on both sides. On the left-hand side, it will cancel to leave us just b. And these are not alike on the right-hand side. There's nothing you can do. It's okay that it looks like a fraction. B is isolated. That was our goal because they ask us to solve for b. Let's go back to numbers and look at a couple more equations. On the left-hand side, notice we have some like terms. We can simplify those as long as we stay on the left-hand side. So the negative 10x and 11x can go together. That will give us a positive 1x, or just x. Bring your equals straight down. If we stay on the right-hand side, we can simplify that expression. 9 minus 5 gives us 4. And now we have just a one-step equation to solve. Go on this side with the x, and you're going to take off the 5. The 5 is added, so we will take it away. Make sure you do it to both sides. Clean up. X equals a negative 1. Different sign, subtract, sign of the larger. Let's look at one more example. This one has some simplifying on each side that we can do. On the left-hand side, the x terms can go together. So we have 4x minus 3x gives us just 1x minus 6. Bring your equals straight down. If we stay on the right-hand side, those numbers can go together. They are different signs. Subtract, sign of the larger, so positive. Now we have a one-step equation to solve. So we'll go on the side with the x, and we're going to take off the 6. It's subtracted, so we should add a 6 to both sides. On the left-hand side, it cancels to leave us x equals 9. X is isolated. That was our goal.